Assalamualaikum. My name is Aida Fatini binti Ahmad Termizi and my partner is Aisyah binti Zulkifli. I will start presenting with chapter 5, which is question 1. Firstly, we will find the hypothesis, which is more than 3000, and then secondly, the level of significance we are using alpha is equal to 5%, and then for the test statistic we are using t-test, sample mean living cost. The formula is equal to average and drag over data from the living cost is equal to 4079.4118, and then for the sample of standard deviation is equal to standard deviation sample and drag of data from living cost, and we will get 3748.8406, and then for the number of Oxford sample, which is n, is equal to count and drag of data from living cost. And then lastly, for the n square root, formula is square root, and then we took this 134, and then we will get 5.8310. And then for the t-test, the formula is bracket d70 minus d18 over bracket d19 over d21 close bracket, and then we will get 1.6789. And then to determine the decision rule, we are using t-test. To get this one, we are using the formula 1 minus alpha, which is 0.05, which is 0.95, and then for the df is equal to n minus 1, we will get 33, which is from 34 minus 31 minus 1, and then for t point IMV, we will get 1.6924, which is the right tail, and then for the p value, the t we will get from d23, which is 1.6789, and then for the n is same, which is 34 minus 1, which is 33, and then for the t, this is equal to 0.0513. Okay, and then for drawing conclusion, for critical t-test 1.6789, and then for the critical value is equal to 1.6924, which is the t-test is lower than critical value, is failed to reject H0. And then for the p value is equal to 0.0513, and then for the alpha is 0.05. P value is bigger than alpha, is failed to reject the H0. Okay, for the conclusion, there is no sufficient evidence to support the claim that the sample mean response living cost can be increased higher than 3,000 ringgit. Okay, now we will proceed with the second question, is ANOVA. Firstly, we need to arrange the vacation per year and education level, and then we will get the result. And then for one-way ANOVA, for the ANOVA single factor, we will need to data analysis, and then go to ANOVA single factor, and then input the range from this one, and then we will place it over here, and then we will get the answer. So based on the table, we will get the critical F-test. The F-test is equal to 0.2414, which we get from here, and then for the critical value is equal to 3.5894, which we get from F, this one, critical value. And then for the p value is 0.8668, which is from this one, and then for the alpha is 0.025. So we can conclude that ANOVA F-test is smaller than critical value and is failed to reject H0. For the p value is bigger than alpha, and then we fail to reject the H0. So in conclusion, there is no significant differences exist in vacation number per year among customers with different level of education. Okay, lastly for the question C, which is chi-square. First we put all the data over here, and then we make a pivot table to get it like this. For the observed value, we just copy the above table and then paste it. For the estimated values, we use the formula is equal to bracket J23 multiply with F25, and then close the bracket, and then over J25, and then drag it all to the right, same as the over here the calculation. And then for the chi-square is equal to F16 minus with F23, close the bracket, and then square it with 2 over F23 and drag it all to the right. And then how to analyze? So H1 is equal to the preference of education level and marital are not related. For the critical chi-square, that statistic is equal to J34, and then critical value is 5.9915, and then we will get chi-square is more than critical value, and then we need to reject the H0. And then for the p value is equal to 0.0442, another one for 0.0031, for is 0.05. P value is lower than alpha, or p value is lower than alpha, we need to reject H0. So the conclusion, the preference of education level and marital status are related, for all respondents are not related.
Hi and Assalamualaikum. My name is Aisyah binti Zulkifli, and I'm going to present about the factors affecting economic growth in Malaysia. This is the data for economic growth in Malaysia. We have to construct and examine the correlation matrix, data tab, and choose data analysis. And we have to choose regression and we click OK. For input Y, we choose year. And then for input X, we choose all of this because this is a multiple regression, and we choose level, confidence level, and then we click OK. So this is the outcome. Next, for question 1b, we go to data tab, analysis, and choose correlation and click OK, and put all of the data to the input range, and then labels, new worksheet, and we click OK. This is the output. So there is no multicollinearity among the independent variables because there is no same value state. Next, we have to examine the correlation matrix. First, for model 1, we have to paste the data and go to data tab and data analysis and choose regression, click OK, and select all the input, and then we click OK. So this is the outcome. For model 2, we do the same step, but we have to drop the growth, choose regression, click OK, and put the input without growth, and then we click OK. Output without growth. For model 3, we use the same step, but we drop the unemployment rate. Same for model 4, we drop the interest rate. For model 5, we drop the trade. For model 6, we drop the inflation rate. So for question D, we have to find the best model. Here we base all the p-value according to model 1, model 2, model 3, model 4 until model 6. And this is the R-square, the adjusted R-square. So the best multiple regression model for predicting the economic growth in Malaysia is model 1 because it has the highest R-square and highest adjusted R-square. Also, p-value for model 1 is more significant than others. This indicates that all the independent variables selected can explain the dependent variables. So for the last question, for question E, so we have to develop a test on assumption on normality. First is the standard residual. We paste it from here and we paste it here. For BIN, we put the -3 to 3. Data and data analysis, we choose histogram and we click OK, and we put the select data, and this is the bin range, which is this one, and then we click labels and output range anywhere near here, and then we click OK. So this is the outcome, bin and the frequency. From this, we click insert and select a chart here. And here is the complete histogram. That's all from us. Thank you.